Hello, my name is Gloria Miori and I'm a senior physics specialist at RaySearch. I'm happy you want to learn more about RayStation. At RaySearch, our goal is to advance cancer treatment through pioneering software for treatment planning. The speed and variety of treatment techniques like MCO, adaptive, fallback planning, and Plan Explorer make your planning routine faster, easier, and more flexible. In this demo, we will give you a general overview of different functionalities in RayStation. Now over to my colleague Julian Uzon, who will demo this for you.
Thanks, Gloria. Let's start with deformable registration. RayStation has a wide range of manual, semi-automatic, and machine learning-based contouring tools. There are also two deformable registration algorithms. Let's have a look at one of them. With RayStation, you will no longer need external software to perform deformable registrations. This tool is an integral part of our TPS, and this integration makes not only contouring, but also dose tracking and adaptive planning much easier. We will look at such a case a bit later in this demo. Here, you can see two phases of a 4D CT scan deformably registered in under 20 seconds, loading time included. This view lets me inspect the deformation field in 3D. It is also possible to deformably register CTs to CBCT, MVCT, MR, or PET-CT datasets. Moving on to inverse planning, RayStation is without question the fastest TPS on the market. The sequence you're watching is accelerated, but the timer gives you a sense of the actual duration. RayStation starts with the fluence-only optimization, and then this fluence is converted to segments using loose machine constraints. An optional collapse cone dose is computed, and the optimization goes on, tweaking MLC positions and dose rate. Towards the end of this run, the machine parameters are strictly enforced and the plan optimized further. The second optimization run starts with another collapse cone calculation and brings the plan to the final dose distribution. Looking at the optimization problem, note the use of EUD-based objectives for some organs at risk. For such situations with multiple overlapping target volumes with different prescriptions, the exclusive dose fall-off objective ensures a smooth dose gradient without the need for algebra operations. This complex 2-arc VMAT head and neck plan is completed in about 2 minutes. A final dose calculation with the GPU-based Monte Carlo algorithm down to 0.5% uncertainty per beam is done in 80 seconds. Yes, RayStation has both collapse cone and Monte Carlo dose algorithms on GPU. If you prefer a more interactive way of planning, multi-criteria optimization or MCO is the right tool for you. RaySearch pioneered MCO with the first release in 2012 and improved it with every release. From the set of objectives and constraints, RayStation computes a so-called Pareto optimal solution space where no objectives can be improved without worsening another. By moving the sliders, you can navigate the space and adjust the priorities of the various objectives. You get instant feedback on the dose distribution, DVHs, and the clinical goals. MCO lets you quickly explore multiple treatment options for your patient, save them, and, for example, discuss them with the whole treatment team during plan review. And now for some dose tracking. This head and neck patient is currently treated with a tomohelical plan. We have acquired 4 MVCTs during the first 4 fractions, and have just imported MVCT for fraction 5. With RayStation, we can compute the dose on MVCTs or CBCTs either using a commissioned CT-to-density table or by bulk density replacement. Thanks to deformable registrations to the planning dataset, we can also visualize the delivered dose not only on the MVCT image, but also on the planning image. Further, we can look at the accumulated dose on the planning image. This lets us compare the planned dose to the effectively delivered dose. If necessary, we can create an adapted plan that can take into account the already delivered dose. For clinics with multiple treatment modalities or unmatched linacs, downtime can be a nightmare. Fallback planning can reproduce a dose distribution using a different machine and/or technique from the original plan. In this example, I use an imported dose as the dose to reproduce. In the fallback planning workspace, I can compare multiple fallback strategies using different machines and techniques from the original plan. I can compare dose distributions, DVHs, and clinical goals to select the best possible fallback plan for my patient. It won't make downtime disappear, but shifting patients to a different machine will be a lot easier now. To close this short demo, we will have a look at Plan Explorer. This workspace is intended for automatic plan creation using either prioritized clinical goals or machine learning models. It is also a fantastic workspace to evaluate treatment plans created with Plan Explorer or by other methods. In this example, we have generated 5 machine learning plans using the same model but different strategies and techniques. Some strategies are more aggressive, others more conservative. With the radar charts, I can evaluate how well each plan, each strategy fulfills best my clinical goals. I can also apply filters using criteria such as treatment machine, dose volume metrics, and more. To compare 2 shortlisted plans in more details, I can go to the plan comparison workspace. There, I can look at dose distributions in detail and DVHs, select the plan that I want to use for treating my patient, and copy that to the plan list. This plan is ready to be quality checked and delivered.
We hope you are as excited as we are about the efficiency gains and the treatment quality that RayStation can achieve. If you'd like to see more, we'd be happy to give you a personal demo. Thank you for watching.